Our team looked at the problem of labor inefficiency on the job site. Our approach to solving this problem is equipping workers with flexible communication tools. Productivity, more achievement per resource, can be impaired by a large number of factors. At the worker level, a tool that increases time spent doing direct work, trades with tools in hand, is ripe for innovation. Construction sites are information-intensive environments, as the previous teams have all demonstrated in various ways, where quality communication is essential. The Construction Specification Institute noted that teamwork communication relies on timeliness of communication. Shellphone enables worker productivity. It provides immediate and targeted communication between individuals or groups on site. It eliminates distance and saves time. Among the many, many possible uses, it can allow real-time management of resources, reduces requirements for in-person meetings, and can allow communication between different trades, different groups, for much wider full-site communication. You can imagine how workers would be empowered to reduce errors and problem solve more easily. The safety context in the construction industry is quite a serious one. High fatalities make a clear case for tools to reduce injury or fatal elements that pose significant risk to workers on site. Shellphone can be used as a tool to promote health and safety best practices to workers, relay health and safety information immediately and widely, make management's job to communicate awareness of health and safety practices easier, as well as comply with OHSA communication standards.
Cool. So going over some of the technical aspects of this project, we have two main components. The first is an iOS client that's used for workers to generate the audio content, so you speak into the phone. And the second is a server written in Sinatra and Ruby. The iOS client is native, and we're using a couple open source libraries in order to enable the communication with the backend, one for deserializing JSON and one of them for actually making those NS-URL connections. The server is using a couple open source tools, Postgres, Active Record, Sinatra Skeleton. It's all hosted on AWS with Heroku. Our code that we generated this weekend is all on GitHub. The links are right there. And if you'd like to write them down, I can give them to you afterwards. All the code is 100% written this weekend. We started from a blank project in both iOS and Sinatra, and then went from there. And it's ready for deployment tomorrow. If you want to roll this out to your crews, see me after, and we'll talk about price. All right. Let's jump into it. So I'm going to log into the app now. My name is John. You type in your phone number. This is how it knows what your unique identity is. And then for the team name, we're going to call it DPR. And everybody who will be involved in this demo is logging in with this team name. So when you log in, you're presented with a list of all contacts inside of your crew. So beforehand, inside of some type of admin console, you would assign crew members to your crew, in this case, the DPR renovation crew. And this would enable us to communicate through that protocol. Now, if we look at this map view here, we can see where all our members are. And for some reason, one of our members isn't in the room with us. I'm going to turn on the audio so you can hear. Hey, Maj. How's it going out there?
It's going pretty good. Getting a lot of work done.
All right, why don't you come and join us in the demo?
Okay, coming out.
So another thing you can see is that along with the voice comms, if you get an incoming one, Maj, you can start a connection with me. how the audio went.
We are connected. We are connected.
Yeah, it's just not showing up on the screen for whatever reason. You can see if you go to the map view image, you can see that I'm lit up so that whenever somebody initiates a contact with you, you can see where are they in the map view. And if you need to relay some information related to you're in a dangerous part of the job site, you need to come back to this area, we're having a safety briefing, anything like that, you have the map view for contextual information. And it's not just for me and Mej. If I want to talk to Brittany, I can click Brittany here. So we can talk with anybody who's on our crew. Yeah, so just brief overview on the features, one-to-one communication. You can click any crew member and talk to them. Location-based alerts. Whenever somebody initiates contact with you, you can go directly to the map view and see where they are. And then third is video. We are close to implementing video so that once you tap on somebody's user icon, not only would they share audio, but you could see what they were seeing to show, maybe something's broken, maybe a tool isn't working properly. But we didn't get to that this time. That's it for us. Thanks for a great weekend.
Okay, so questions from the judges?
You mentioned that you didn't get to it this time, so have you tried this before?
No. Well, we started with this last night. We had the idea of voice over IP communication, and that seemed really outlandish, but then we started digging in and decided we'd be able to pull it off. But yeah, we came up with the idea last night. I think the first commit was 11 a.m. yesterday, and you can see the GitHub logs if you want to check. We didn't start from preloaded code.
So it looks like this is tracks location. This is two questions. So what are you using to track that location, and what's the accuracy of that location?
So the accuracy of the location is dependent on what metrics you have enabled in the app. So default, Apple allows you to set the accuracy. We're using the highest accuracy that they have, the driving accuracy, which will give you up to about 50 meters if you're using just GPS. If you go down to Wi-Fi, it can get into the 15 to 20 meter accuracy.
Okay, then if there's no Wi-Fi or useful GPS on the cell site or on the construction site?
Yeah, we can set up a system similar to what everybody else talked about, where you host a server and it relays all the information through that locally. But obviously, if you can't have Wi-Fi, the devices need to connect to one another in a reliable way. So there's no way to do that.
So I'm struggling to figure, the map is nice and all, but I could do this with a cell phone. And there was and I can't remember the brand anymore, they had a click-to-talk, which Nextel, yeah, had the walkie-talkie solution. And then between that and there's apps that always you can get location. But based on your answer that you just gave on, well, if there's no cell coverage or anything else, then okay, I actually see this could, I think what I'm trying to say is you may want to focus more on the use case where there is not reliable cell coverage. And say, look, we can put in a voice communication system, we can use their existing cell phones, just put this server here, we put this broadcast antenna that can at least cover the whole place, and boom, now you guys can talk to each other even if you don't have cell coverage out in that area. But for a place that has cell coverage, probably easier just to use a cell phone.
Yeah, that's a really good point. One of the things that we saw as a useful feature for this app is that crews changed on a daily and weekly basis. So if you showed up on a job site and logged into the crew with that unique identifier, then you'd immediately see all of your crew members and you wouldn't have to gather their phone numbers in order to initiate contact with them on the job site. So it would just be show up at the job site, type in the ID, and then you immediately have your crew there and you can communicate with them that way.
One of the next features too would be to select a certain number of people that you want to talk to. Like you could select 3 in a specific area, so the voice gets pushed to just those 3, or you could send send it out to everyone on your team at once. So those are things that just regular cell phones you can't quite do.
Yeah. There's a program I wrote a long time ago. I've already forgotten half of how I wrote it, and I don't even remember the service anymore. Where I wrote a call down service and a distribution service, which does the same thing. You go on the website, put in your cell number, and now you're logged into a system. There's a veterans hackathon, where if you had your commander had to get a hold of your soldiers really quick, you did it all through the web. But again, same restriction. It only works with their cell coverage. So it's killing me to forget the platform. It's a super known platform. Everyone knows it. So there's still things that you may want to research that kind of does a lot like this, but none of them work if there's no cell coverage. So I still think.
I think in a Boxer.
No. It's, Twilio. It was really easy to write. Wrote it like in a week. But all those things depend on cell coverage or Wi-Fi. And so since your system here, and I was looking at the technology used, sounds like something you just throw on a server and just support your own local Wi-Fi network, then that in itself could be a pretty big win to get around the whole Wi-Fi and cell coverage problem that sometimes you get on the site.
I like it.
You mentioned that your auto-generated alerts. Is it generating based on location, or does it require a human being to make that judgment call?
So the alerts are audio. The audio works in the background, so once you have the app open, it initiates with you. So the alert would be through the earpiece, somebody would start talking to you.
But how would that person know that you're in a dangerous area? That's what I'm trying to figure out. Does
Oh,
it
they
require
would
a human
know.
being, or?
Yeah. So that would be human. They would have to know that that is a dangerous area. We don't, designate certain zones in the map as dangerous. That would be human interpreted.
Any other questions from the judges?